In this video, I'd like to review the properties of right triangles and the associated trigonometric functions that go with it. As I start here, I'd like to go over some basics, which is it's got three sides. So we're off and running here. The sum of all three interior angles will equal 180 degrees. With a right triangle, the right angle between the two legs of the triangle form a 90-degree angle, which means the other two angles are complementary angles. Whatever this one is, this is 90 minus. So these two have to add up to 90 as well. One of the first theorems you learn with right triangles is what's called the Pythagorean Theorem. And it shows the non-mathematical addition where you can have a side of 3 and 4 and this doesn't equal 7 because we're in two dimensions here. The Pythagorean theorem relates the fact that if we take a triangle and we square this side and we add it to this side squared, it will equal the length of this side squared. And what math typically does is, in most textbooks, what I've seen is they will arbitrarily use the letters A, B, and C, where A and B are always the legs of the triangle, and C is always the hypotenuse. And depending on where you see the textbook, A and B might be over here. It really doesn't matter. The only thing I will bring up is the fact that the A does not stand for adjacent when we get to looking at the sides of the triangle. So this just says that if I know 2 out of 3 sides of a triangle, right triangle, I can solve for the third using the Pythagorean theorem. So for instance, if I have a side here that is 3 and a side here that is 4, and we look at the math that goes with this, we would be able to say 3 squared plus 4 squared will have to equal the hypotenuse squared. So C is always reserved as the letter that denotes the hypotenuse. So we have 9 plus 16 equals C squared. What you're going to see is we get a perfect square here. 25 is C squared. Take the screw to that. We're going to get 5 equals C. We only work in positive dimensions here. And so this is one of the unique triangles that is formed, which is a 3, 4, 5 triangle. That seems to be the easiest way to solve for most of the guys that I teach. What is a little more problematic is when you have to solve for one of the legs. And that gets a little more difficult. So if I leave this as a 5, and then I say, this is a 2, what is this side over here? So question mark. This is where you have to really pay attention and just write the equation down if you keep having trouble with it. And I'm just going to say this is my side A over here. And I'm just going to say A squared plus 2 squared equals 5 squared. A squared plus 4 equals 25. Subtract 4 from both sides. A squared equals 21. And then A is the square root of 21. And my guys know I do not accept anything except a decimal answer, because that's how physics guys roll. And so 4.58 is how far I have these guys take it. So 4.58 will be the length of this side right here. So that's Pythagorean. Mainly used when you know 2 out of 3 sides.